Hello everyone. Today we are going to talk about 4.8G, finding equations from the roots. So you will find equations when you have the irrational roots today. So last time we learned how to find the equation from the imaginary zeros, right? So do now. So let's start with the do now. So you have imaginary zeros, -3 plus 4i's. Can you, what is the other root? And then find the original equation. I will give you about 4 minutes. All right. Okay, let's go over together. So what is the other root? Yeah, it's a -3 minus 4i, right? We say it's a conjugate. So a plus bi, same with a minus bi. So they come out, they come with the pairs, right? So if you remember the quadratic formula, it has a plus minus in the middle. So that will make, help you. So now to find the original equation, what should you do? Yes, you should set this x equal to one of these. Both of them will give you the same answer anyway. So one of them, which is now, let's go with the -3 plus 4i original one. But if you use minus 4i still, you will get the same equation. But now what is the first step? You move this -3 to the other side, right? Second step. So x plus 3 equal to 4i. And now we don't want to have a I imaginary. So how do you eliminate? Yes, you square them, right? If you square both sides, you are going to remove the imaginary number. So like this, when you square it, now this one is the FOIL, not be careful, it's not x squared plus 9, right? This is x plus 3 times x plus 3. Makes sense, everybody? So now, this is a 4 square I square, and the I square is equal to, yes, -1. So you will have x squared plus 3x plus 3x plus 9 equal to -16. This is -16. Now we need to move this -16 to the left side by adding 16 both sides. So move it. And then 3x plus 3x becomes 6x. So 9 plus 16 combined, then you will have x squared plus 6x plus 25 equal to 0 will be your original equation. See, you can do it, right? Now today's lesson also very similar, almost the same steps, but we are going to deal with irrational zeros. All right. So conjugate, I think everybody already know. So it has 1 minus I has a 1 plus I, a plus bi form, right? A plus bi, a minus bi. So we'll just skip. Now, when you have, we call this radical, square root. This square root is irrational numbers, right? So irrational numbers. That's why we call this irrational zeros. So when you have one, when you know one irrational zero, so how do you find this one? How do we find out the other root? Again, irrational zeros has a conjugate, come out as a pairs. So a plus bi, instead of a plus bi, now it's a plus b square root, something like that, right? But this one is a minus, then this will be plus, and then the square root must be the other, always the later part, okay? So a minus b square root thingy, then a plus. So half plus square root 2 over 2. And when you find out the original equation, we follow the same steps, a little bit different because this is a fraction, right? But not difficult. So let's set this x equal to the roots, right? X equal to half minus square root of 2 over 2. If you have a plus, same thing. You will get the same answer. And then we should isolate square root 2 over 2. All right? By moving half, right? You move a half. So x minus half equal to negative square root of 2 over 2. Now, one more time, we never had any fraction in the original quadratic equation, right? If you just square it, you will have a still fraction. So how do we remove the fraction, which is a denominator? How? Yes, we multiply by denominator 2, right? So we multiply 2 to the every terms. So 2 times x, 2 times this, 2 times this, right? We multiply 2 to the every terms, right? So you have 2x minus 2 times, so 2 and denominator same thing, then you cancel. That's why we multiply by 2, right? So 2 and 2 cancel. Now negative square root of 2 here. So 2x minus 1 equal to square root negative 2. Now we need to remove the square root. How do you remove it? Same method, we square both sides, right? When you remove the imaginary number, also you square it, right? Because if imaginary square, I square become negative 1. But now when you remove the square root, also you square it. Then you will have 2x minus 1 square is equal to negative square root of 2, and put them in the parentheses and square. If you don't, you get the wrong answer. And then simplify, right? 2x minus 1 times 2x minus 1, and negative become positive, right? Square root and square cancel, and then inside the square root you have 2 comes out. Square root and 2 square cancel each other, so 2 will come out. And then what should you do? We FOIL, right? So 4x squared minus 2x minus 2x again, minus become plus 1. And then I needed to move 2 to the other side, right? By subtraction. And then you combine like a terms here. So 4x squared, if you combine, minus 4x, 1 minus 2 is negative 1. So minus 1 equal to 0. Everybody understand? It's very similar to the other lesson, right? When we had the imaginary zeros. Today we deal with irrational zeros. All right. Then this is error analysis. So can you find out, identify the mistakes and then correct? All right, let's do it together. So first step, you set x equal to this, right? And then move negative 3 to other side, x plus 3, very good. 4 square root of 2, very good. And square both sides in the parentheses, very good. X plus 3 times x plus 3 is good. 4 square is 16. Square root of square cancel. 16 times 2, very good. Now, when you multiply this, oh, you should FOIL, but you said x squared plus 9. It missed right here, right? So step 5 is error. So how do you correct it? Step 5, you should FOIL it. X squared plus 3x plus 9 equal 32, and move 32 to here, and 3x combine. So 6x, 9 minus 32 is 23, minus 23. Everybody understand, right? So we are done here. So if you go down, you will have 6 questions. Please finish it and hand in, okay?